Hello all. In this video, we are going to discuss about SLR parsing. So we are going to parse the input string ID star ID plus ID using the SLR parsing table. So we have constructed this SLR parsing table in the previous video. And SLR parsing, actually the LR parsing program is common for all three types of LR parser. There are three types of LR parser. Simple LR, that is we are discussing about simple LR. Then other two LR parsers are canonical LR and look-ahead LR. So the LR parsing program is common for all three types of LR parsing, but the table construction algorithm is different for different types of LR parsing. So now we are going to parse this input string. So we need to use stack input and action. So the stack is a memory unit. Initially it has the input initial state, so 0, and in input buffer we need to store the input string followed by the dollar. And there are four types of actions can occur here: shift, reduce, accept and error. So we need to refer the SLR parsing table, and this go to table is used for reduce action, that we will discuss it later. So first the stack may initially has the initial state 0, and it can be followed by grammar symbols and state. So a state, grammar symbol, state, grammar symbol, state. So this is the way to store the grammar symbols, stack symbols. So initially we need to store the initial state. Whenever we want to store a grammar symbol, it should be stored along with the state. So every time the top of the stack should be a state. So the SLR parsing table has state as a row. So we can refer row and input symbols for the action table. So first we need to check 0 and ID. The action table for 0 and ID. So 0 and ID is S5. S5 means shift 5. So we need to write shift here, and we have to shift the current input symbol ID as well as this 5 onto the stack. So shift operation means we need to shift the current input symbol onto the stack along with the 5. So now we need to advance the input pointer to the next input symbol, that is the current input symbol is star. Now then again check 5 and star. So 5 and star is reduce R6. So reduce by the production number 6. Production number 6 is F tends to ID. So now we need to do the reduce action. Reduce action means we need to replace right hand side of the production by left side. That is we are having the handle on the stack, top of the stack. So that handle should be matched with the right hand side of the production, and it should be replaced by the symbol on the left hand side. So but in SLR parsing, LR parsing tables, the grammar symbols are coming along with the state. So first we need to calculate length of the right hand side of the production. So here the length of ID is 1, then multiply it by 2. So we will get 2. That means we need to pop these two symbols from the stack. So ID is considered as a single symbol. ID is a symbol, 5 is another one. So two symbols must be popped from the stack, and then we need to push left side of the production. So F, then 0F. So because every time the top of the stack should contain a state, so we need to refer go to table for this one, 0 and F. So 0 and F is 3. That should be pushed onto the stack. So whenever we do the reduce action, first we have to calculate length of the right hand side, then multiply it by 2, then pop those that many symbols from the stack, then push the symbol on the left hand side, then refer the go to table for the state. And in reduce action there is no change in the input buffer. So continuously we need to do this. 3 and star. So 3 and star is R4. So reduce by production number 4. Production number 4 is T tends to F. So here length of the right hand side is 1. Multiply it by 2. So two symbols must be popped from the stack. So 0 is on top now, top of the stack. Then push left hand side of the production, that is T. Then 0 and T. 0 and T is 2. then no change in input buffer. Then refer action table for 2 and star. 2 and star is shift 7. So shift 7. 7 means we need to push star and then 7. One symbol from the input buffer is shifted onto the stack along with 7. Now advance the input pointer to the next input symbol. That means remove the star from the input buffer. Then 7 and ID. 7 and ID is S5. So shift 5. 5 means ID and 5 must be pushed onto the stack. Advance the input pointer to the next input symbol. Now 5 and plus is reduce 6. So reduce by the production number 6 is F tends to ID. Now length of the right hand side is 1, multiply it by 2. So we need to pop 2 symbols from the stack. So ID and 5 must be popped from the stack, and we need to push left side of the production F. Then 7 and F. 7 and F is 10. 10 should be considered as a single symbol. No change in input buffer. Then 10 and plus is R3. So reduce by production number 3. Production number 3 is T tends to T star F. Now length of the right hand side of the production is 3, multiplied by 2, so 6. 2 into 3 is 6. So we need to pop 6 symbols from the stack. So 1, 2, 3, 4, 5, 6. So 0 is on top of the stack right now. Then we need to push T and 0 comma T. 0 comma T is 2. No change in input buffer. Now 2 and plus is R2. So reduce by production number 2 is E tends to T. So length of the right hand side is 1. So we need to pop 2 symbols from the stack. Then we need to push the E. So pop 2 symbols, push E, then 0 and E is 1. Now 1 and plus is shift 6. So shift, and so shift means we need to shift plus as well as 6. Then remove plus from the input buffer. Now 6 and ID. 6 and ID is shift 5. So shift ID and then 5. Now remove ID from the input buffer. Then 5 and dollar. 5 and dollar is reduced by production number 6. So reduce by production number 6 is F tends to ID. So pop 2 symbols from the stack. Then we need to push F and then 6 and F. 6 and F is 3. Then 3 and dollar. 3 and dollar is reduced by 4th production. So reduce by 4th production is T tends to F. So length of the right hand side is 1. So we need to pop 2 symbols from the stack. So pop 2 symbols and then push T as well as 6 and T. 6 and T is 9. So now 9 and dollar. 9 and dollar is R1. So reduce by production number 1. Production number 1 is E tends to E plus T. So E tends to E plus T. Now length of the right hand side is 3. So we need to pop 6 symbols. 1, 2, 3, 4, 5, 6. So now push E as well as 0 and E. 0 and E is 1. Now 1 and dollar. 1 and dollar is accept. So the action is accept. So the actions are shift, reduce and accept. Sometimes we may have to refer to the blank entry. In that case we need to write error. That is, the input string has some syntax error, so the parser cannot parse the input string. So in this example, the SLR parsing table has single entries. All the entries are single entries. So we can say that this grammar is SLR of 1 grammar. Sometimes it may have multiple entries. So in that case we can say that the given grammar is not SLR of 1 grammar. So in the next video we will see an example for not an SLR of 1 grammar. Thank you.